Today I'm going to be talking about accelerating ML workflows with Databricks. Some of you have Databricks experience. I think some of you do not. And I think this next slide is just some introductions. I think you've met most of the people from Zorbix here. Myself, I'm Tyler Faulkner. I'm a data engineer at Zorbix. I'm consulting full-time in an insurance company. And then Asif Bakar, the CEO and president of Zorbix too. Now, what I'm going to be covering today, there's going to be three main points I'm going to cover. MLflow experiment tracking, Databricks feature store, and Lakehouse drift monitoring. Most of this is going to be focusing on MLflow experiment tracking. Then Databricks feature store, we're kind of just going to scratch the surface of that. We're not going to go, it gets kind of complex. We're just going to kind of show how to do a basic setup. And Lakehouse drift monitoring, again, we're just going to kind of scratch the surface and show what that's good for. So to start off, I do want to note most of this is going to be within Databricks. I have a couple slides just to kind of ground where I'm talking to make sure I don't lose track of where I'm going. But most of this is going to be going into Databricks and actually like running notebooks and showing some code snippets and showing how to do things. So just to talk about MLflow, if you don't know what it is, it's a scientific library for tracking machine learning experiments. It's open source. It's pretty broadly used in the data science community. Databricks is directly integrated with it. So they have a term in MLflow, I mean, it's a generic term too, called experiments. So you run an experiment, you can log hyperparameters that you use, and you can configure it how you want. So you can log any parameters, you can customize that to your needs, you can track outputs of training a model, our AOC scores we're going to use for our example, or any kind of scoring you want to see. You can create models for this, and one nice thing with MLflow is there's constructs in it to kind of package your model together. Since this is like a scientific library, most of this is about reproducibility and visibility in your experiments. And Databricks on top of that really helps out because there's already a lot of visibility and stuff with Unity Catalog and all the fine-grained permission controls you get with that. Another cool part about MLflow that's integrated directly from Databricks is the registry. So this kind of goes hand in hand with the models. You can register a model to a specific name. You can label, if it's currently in production, you can have multiple versions of that model, put labels on them if it's in production, if this is an old archive model, and you'll see kind of the basics of all of this as we get into Databricks. There's kind of another section of MLflow that really isn't in Databricks because Databricks has its own answer to it, and I don't know how really it's used anymore. It's called MLflow projects. It's kind of like an infrastructure packaging tool, kind of a containerization tool to run your models kind of anywhere. But Databricks kind of is kind of its own solution to that kind of need. So it doesn't really use that aspect of MLflow too much. So now, just some of the benefits of kind of this integration with MLflow and Databricks. I've kind of already mentioned this, the visibility. Another nice thing is since it's directly integrated, if you have Databricks already, you have all the infrastructure you need to do this tracking and model management just right there. You don't have to do anything else. Since it's open source, you could run your own server if you wanted to, but if you have Databricks, you have it right there. And with the Databricks, you get seamless deployments in CI/CD, so you can easily make a model and easily deploy an endpoint for it. So you can reach it from anywhere in the world, theoretically. And another benefit directly from Databricks is the scalable performance. You can set whatever kind of cluster you want on it. You can set the scaling on it, so as more people hit it, it will have more compute that it can use. All right, now I'm going to transition into our demo. There's just a couple things I just want to kind of maybe refresh, update if you haven't really heard of them, just to make sure we're all on the same playing field before we go into it. So we're going to be using scikit-learn, basic learning, machine learning library to do very basic things. We're going to be training a random forest model on the wine data set, and I'll talk more about the wine data set once we get into it. First, I just want to talk about random forest models, where they come from, what they are, so we know what we're actually training here. These come from the idea of decision trees. So here's a really basic one for a classification problem. So we're trying to predict a label, buy or don't buy. There are, how many features are on here? There's color, make, mileage, and model. There's 4 features that we can use to predict if we want to buy this car or not buy this car. So if color is red and the model is greater than 2010, so let's say it's 2013, we should buy it. This example I pulled must have been from the EU somewhere. The mileage is in kilometers. But if we don't have a lot of mileage, then we want to buy it. If we have a lot of mileage, we don't want to buy it. One thing I do want to point out, though, is with the color, as you can see, only color red and color yellow show up in this diagram. That's kind of highlighting that based off the data that it saw, people are only going to buy a car if it's red or yellow. Apparently, according to the data set this is trained on, nobody's going to buy a blue car. It has to be red or yellow for the people to buy it. And if it's yellow, it has to be a Ferrari. Otherwise, nobody's going to buy this car. So random forests are kind of an idea built on top of decision trees. So a decision tree predicting an outcome, if then statements predicting a big outcome. Random forest, whole bunch of those trees, essentially as a democracy. We have a whole bunch of them trained on their own features, on their own portion of the data, and they're all going to vote on what they think the answer is based off of whatever inference data you're sending it to predict. And the benefit of this is it reduces variance. It makes things very stable compared to using a single tree. And I think that's all for my little spiel. So now I can actually see this in action, which is the fun part. So the first example here, all of these examples I'm going to be going through are by Databricks, me walking through them, running them live in front of you. And I actually forgot to start my cluster, so I'll walk through it as this is catching up. So hopefully, yeah, it should still have the output from the last time I ran it. So this is a data set of white wine and red wine. All we're doing is we're going to combine these together, and we're going to add kind of this generated label of is red. We're going to use this one of our training labels. Basically, the red wine is red wine, white wine is not red wine. We put them together, and then we get this. So we can, as part of like the first thing in the data science workflow, you're going to look at your data, figure out what's going on here, what features you have, do some basic analysis before you just start throwing the data at a model. So I don't know, has anybody here used the wine data set? Yeah, I was about to say, I know at MSOE, I don't know how much they do it anymore. Have you used the wine data set at MSOE? I just see because you're wearing the shirt.
I am a software engineering major, so I
don't. Oh, okay, so you might not.
We did.
We did, yeah, that's what I thought. I was like, I remember.
At some point, either intro to data science or
like
machine learning principles.
Yeah, this is kind of a famous toy data set because it's not very large and it's kind of easy to see certain variables within it.
I actually think when we were doing random forest for the first time.
That makes sense. They probably got.
I'm getting like flashbacks.
Yep. So this isn't really going to focus much on the training. It's more going to focus on how it integrates with MLflow and how we do all the tracking using that. So here's our data here. As you can see, based on the labels, most of these are simply different chemical properties of the wine. Sugar levels, acidity levels, got pH over here, density, sulfates, and then over here we have our categorical labels. So we have that is red. It's either yes, it's red, or no, it's not red. And then we have quality, which I don't remember exactly how this is derived. I think these are from wine people who rate wine or something, and they give it a quality label. But what we're gonna be doing is we're gonna use that quality wine and turn it into essentially a Boolean. So our next plot, if we just look at our different quality levels, we see that most of the wine is below 6. 6 and below is where most of the wines sit. And 7, 8, and 9 don't have a lot of wines. This example here decides the cutoff for a high quality wine, as they define it, is 7. So 7 or greater, that's a high quality wine. Lower than 7, that's a not high quality wine. So we do that split here, pretty simple. And now we're just going to do some visualizations. So I kind of want to see, it's just to kind of bring everybody in on this. You don't really have to worry about what the labels are. Can anybody see there's 2 features that will be deterministic of the model? I guess importance, is the word I'm looking for. There's 2 features up here. You can, and if anybody has it, you can just kind of say which chart it is. Any ideas? What we're looking at here is based on that high quality label, which feature, we're looking at the standard deviations. These are all box plots, standard deviations. So we're seeing how these variables affect the outcome. Anybody see which features might be important? Anybody, you want to shout it out? I see you shaking your head.
Yeah, bottom right to the top. There's the left and to the top.
This one?
Yeah.
And this one, yep, you got it. So this one here, it's pretty tiny. This is the density level. So you can see there's a little bit of overlap, but generally high quality wine has a slightly lower density than a low quality wine. And it might be hard to see from all the way back there. So there's a bunch, they put too many plots in one chart here. And then here is the alcohol level. As you can see, a high quality wine generally has a higher alcohol level compared to a low quality wine. So these next few cells, basically just checking that we have valid data. There's no nulls in this data, so we have a good data set to work with. Now the first thing we're going to do is we're going to make our initial baseline model, and we're going to split our data into a train, test, validation split. Training is going to be used to train this baseline model. We're going to use the validation later on, which we'll come back to train to tune that baseline model to improve the score. And then the testing is a subset of the data that the model never sees, so we can get a score off of it, see how well it's performing. So now, here's our train test split. That just splits it up there. Don't really have to worry too much about that because I want to focus on the MLflow concepts. So now we come here, and there's some initial code, but the point that I really want to mark is where we start using MLflow. Let me make this a little bigger. There we go.
Finally, I can understand.
So before we do anything, before we run any of our code, we have this with mlflow.startRun. We give it a run name, untuned random forest. And everything, you see everything, this is Python, so it's all based on indents. But everything underneath this with statement is all going to be within our experiment context. So all this code, this is the code that if somebody wants to reproduce later, this is the code that they want to reproduce. All the other code is mostly just set up for our environment, more or less. So very basically, we have our one parameter for this instance. We have a number of estimators for our random forest. We pass that into our random forest classifier. And then this fit here is the training. So we trained a random forest model on our training set. We want to now get our score off of that. We calculate our AUC score. And now the important part with MLflow is we can now log these. And then I was trying to point out before that you can really log whatever is important to your specific experiment. There's no kind of rules saying you have to log this or log that. There's two kind of areas where you can log things. You can log parameters, things going into your model that affect its performance, and metrics, which are outputs from your model determining how well it ran. And those can be whatever you want. All you're doing here is saying, okay, this parameter name was n estimators, and here's what the value of that was when we did this experiment. We're logging a metric of our AUC score, seeing how well our model ran, and this variable represents that number that's calculated. And I see my cluster finished, starting up, so I'm going to quickly just kind of run through and rerun all these cells so you can kind of see some. I want to show how Databricks interacts with MLflow, so I actually want to run this cell so you can see it where it pops up in Databricks. Hi, how's it going? All right, let me just catch up my data here, rerun everything that I went through. High quality charts. I'm just rerunning everything just to make sure there's a variable in here that I missed so nothing breaks. That one. All right, almost caught up. All right, so now I went through how the experiment works. Now I'm just going to run it so we can actually see some output from that. And as you can see, we logged one run, and yeah, this looks like live output. We logged one run to an experiment in MLflow. I believe these links here will go directly to where I want to go in Databricks. So you can click on those links, right? And this is a Databricks specific thing since it's all kind of integrated. It'll give you those links right in the cell that you're using so you can jump to it. So here, this is our experiment within the Databricks view. This is the Databricks UI view of MLflow experiments. Another way to get to this is in the sidebar. Underneath machine learning, there's our experiment section. So as I scroll down here, you can see there's a kind of handful of other experiments that I've ran in the past. And the name is always going to be the name of your notebook. This is kind of a Databricks specific thing. And then when you go into that, so this notebook ran these experiments, and you can see untuned random forest. That's what we called our experiment. And if I wanted to, I can click on it. I can see a bunch of different stats on it. AUC score, that was our metric that we logged. And as you can see, you can log it multiple times if you want, and then it'll keep track of the min and max of that variable. You can log our parameters so you know what variables we're passing in, so we can reproduce this run. A nice thing with the Databricks view, you can, if you wanted to, you can make charts and stuff for your model runs. So if you wanted to log like your ROC curve or something, you can throw a chart here so all your engineers can come to this place and see all the metrics. Another nice thing, talking about the reproducibility, if I jump back to the notebook quick, there was kind of this craziness at the end. All this is basically doing is it's taking everything that was used to make this run into a nice little package that you can run somewhere else. So reproducibility, so another engineer can take that code, and where that ends up is in the artifacts for that run. So everything that we passed in there, it gets serialized to some form into an object so that somebody else can download it, rerun it, and they can, in theory, see the exact same results that you did and rerun the experiment. So that's how a basic experiment works. You define a run name, and then you can define parameters and metrics you give to it. And there's way more advanced stuff you could get into, but that is a very basic experiment run. All right, so now we want to actually, so we've trained a model. Let's actually put this model somewhere. Right now it's just sitting in our notebook. It's sitting technically as an artifact also within our experiment, but we want to reference this model later on. Maybe somebody else has a notebook where they have a whole bunch of tests they want to run on the model or something. So we want to put this into our registry. First, so from our random forest model, we can pull out the important variables. And this kind of confirms what we saw earlier. So that alcohol and density value are the most important variables that determine if this is a high quality wine or a low quality wine. And the other variables have some impact, but not as much as alcohol and density do. All right, so we keep going. Now we have our model. Let's register it to MLflow. This here is basically just saying, hey, look at all the runs I just did. Find the one that was called untuned random forest. This is the one I just ran called untuned random forest. We're getting the ID, and this is just to make registering a little easier. And let me run this. So now let's actually register this to put this into our registry so somebody else can use it. So we give it a model name. This is completely arbitrary. It's whatever you really want it to be. You probably want some kind of standards, especially in a business context. For this case, we're just calling it wine quality, and we can use MLflow.register model. All this is doing is this is pointing to the run we just ran and that artifact. So remember we committed that artifact. This is essentially a special path to point directly to that artifact to reference it. And then this is the model name. So we're saying, okay, this artifact equals this model. And once I run this, it takes a few seconds. It has this sleep here. If it's a bigger model, it might take a little bit more time to push to the registry, but otherwise it takes very quickly. As you can see, created version 1 of model wine quality. So now we can go to another page in Databricks, go to the machine learning section, and now we can go to the models page. And we should be able to see we have a wine quality model here. Latest version is version 1, so we've only pushed one model to this. And we can click on this. A nice thing with this is you can leave descriptions, you can add tags to your models, so it's a little easier to find things, especially if you're working in a big company. Maybe you're developing 100 different models at once or something. You're going to need some way to easily track those. And MLflow has that all built directly into it, and Databricks is all wired up to it. And since this is Databricks, there's fine-tuned permissions, so you can set up exactly how you want people to access this specific model, and that's all respected everywhere within the Databricks environment. All right. Now jumping back to our notebook. So we've ran an experiment, made a model, we've registered our model. So now people can use it. So now what we want to do is, okay, we have this model, we only have one model. Let's label this as our production model. This is a kind of a specific MLflow language here. They have a term called stages, so you can stage it to production. There's production, staging, and archive, I believe, are the 3 stages. I'm not really sure if you might be able to make custom ones. I'm not positive on that, but I know there's production, staging, and archived. So all this code's doing here is labeling it as production. You can also do this through the UI if you wanted to. Let me go to the models tab. So if I go to version 1 here, I just labeled this as production through my code. Let's say I wanted this to be none instead. I can click here. I can leave a comment why I'm changing it through the UI. Click OK. It'll switch it to none. So nice thing about Databricks is you also get the opportunity to do this through UI. So maybe your less engineering people at your company can also interact with your models and stuff without having to understand every line of code. I'm just going to put this back to production for demo's sake. And now this is just a quick example just showing how to load the model. Basically just a one-liner pointing to another special path, which is just the model name / production. And that will grab the latest production one. Whatever version that is, when it's labeled in the stage production, it'll grab that one. And just to confirm, let's see, we should see the exact same AUC score that we did during our training up above. I don't know if that actually popped out anywhere, but essentially that was just an example just showing how to run the model ad hoc anywhere you want once it's posted somewhere. All right, so now we want to do our hyperparameter tuning. We're using a couple of libraries here. I'm not going to go too much into the semantics. One of them is to do this hyperparameter tuning really easily. That's hyperopt. And then XGBoost is an algorithm / library. You might see the term interchangeable with that one. That makes decision trees really good. So you can think about it simply that way. It's an optimized algorithm for making decision trees a lot better. Here, we're just giving it, okay, we want to search every possible parameter within this space. We're making a giant grid essentially, and the program's going to run through every possibility for us. And we just set up a little function here, basically. So if you notice, here's some more MLflow stuff. XGBoost, as I mentioned, is a library / algorithm. It has some built-in connections with MLflow, so it can do some logging for you. But here, in this train model function we have MLflow.startRun nested equals true. So if we see where this train model is actually being called, it's in this fmin. This is a fancy function to run everything for us. Don't have to worry too much about that. But you see, before we run this function, we have start run XGBoost models. So our run name is called XGBoost models, and each model that's training underneath this one is going to be a nested run. So it'll kind of organize them, okay, XGBoost models, here's your 30 different runs or whatever it is that happened underneath that. And I'm going to run this now. And this takes about 10 minutes to run. And I'm going to come back in a little bit and we can look at the results of this while this is running in the background. So if you look at it already, it's logged 8 runs to an experiment. And if I just go to the experiment page, we can actually see it running live in the Databricks UI. So you can see where the progress is. As you can see, here's our XGBoost models, and there's a little plus button next to it. And here is all the nested runs underneath it. And as you can see, it gives it a random name of an adjective and a noun and then a 3-digit number. So you get a lot of fun names, salty slug, adaptable pig. And this is all just random generated from MLflow. It's just a fun little quirk. And this is going to keep going until it finishes. As I said, this takes about 10 minutes. So I'm going to kind of, yeah, go ahead.
Could you just comment and show maybe what size of a cluster you're using?
Yeah, I think, I don't even remember how big I set this. It might be a little bigger than need be, just to make sure it ran a little fast. Yeah, this is a slightly bigger one than is probably needed for this subset example. It's 4 cores and 30.5 gigabytes for whatever reason. It's 30.5. So it probably doesn't need that much memory. But, I mean, this is a relatively small, I mean, 4 cores isn't crazy because things I've done at work, we'll go up to 128 cores and real fast if we need to. So this is a very minimal example. And I think, are we trying to get at, like, if you have more cores, it'll run a little faster?
I'm just curious what you got under the hood there. And how many DBUs is that?
It'll show 1 DBU an hour.
Okay.
So it's a relatively small cluster. Yeah. This is a relatively cheap process, is what this 1 DBU an hour is telling us. Because how much is it per DBU hour? It's like 50 cents. Yeah, it's like below $1. So I mean, I run this for an hour. It's going to cost $1. instant. It's a little bit less than that, and there's some other math involved, but more or less, it's around $1 an hour.
I always like to compare it to how much it would cost me to buy a machine.
Yeah. And this is running. So while this is running, I'm going to start talking about the next topic, and we'll kind of pivot back to this one. This is done to kind of finish up the rest of the MLflow stuff. All right, so to kind of ground where I'm talking about next, let's jump back into the presentation. I just have a couple slides for the next few demos just to kind of introduce it. So the next thing I'm talking about is the feature store. And what this is really nice for is it does a lot of the things that might seem simple for you, but when you get to scale and you want to get to production, it really simplifies a lot of things for you, especially if you're within Databricks. One thing, the way we're going to use it is basically we can set up a feature store, which is basically we can provide just an ID, and Databricks will do the lookup to find all the features that we need to either train our model or infer our model. So like let's say we have a database of users for ads or something. Each user has a user ID, and we have all those features in Databricks. We can just give the model the ID of that user, and it will find all those features for us and then run the inference based off of the data in Databricks. So you don't need to do any of that manual moving data around, giving it to your model. A lot of that management is done for this, so it makes scaling a lot easier. Some other nice things, online serving endpoint. So you can expose features through an API, or you can also integrate it directly with an MLflow deployment SDK, another side of MLflow, so you can easily call this model and run it by just passing it an ID. There's online tables, which are a semi-newer feature of Databricks. I'm not going to talk about them too much, just want to mention them. These are essentially for if you need like really fast inference time. These are essentially key value stores. So you give it an ID, it's going to find those features for that ID in milliseconds compared to, I don't know, seconds. So it's just a really fast way to find data. And again, that helps with the scaling. So I'm just going to touch the surface of this one. There's a lot more under the hood in terms of like time series guarantees and training data to make sure there's not leakage. Like let's say you're working with weekly data, weekly aggregates of data to train. If you're training on week 7, you only want to account for weeks 1 through 7. You don't want to account for weeks 8 because in terms of that training, week 8 hasn't happened yet. So it has some guarantees built in place to make sure there's no leakage like that. So if you're looking at time series data, it doesn't jump ahead on accident. Just a couple use cases for this. A lot of this is kind of real-time detection to some degree. Fraud detection. You want to get those as fast as you can. A new data set or maybe a new record comes in. You're at an insurance company. Maybe you have some basic system to see if this is fraud or not. That's just one broad example. You can use that for this. Real-time personalization. Kind of touched on that. Google with ads. When you open a website, it's picking all those ads you see when you load the website. So relatively real time. So you can use it for something like that. So you can just throw it an ID when he loads up the page, and it can send back the ads that it thinks will be best served for this user. The ads that the user is most likely to click on and probably buy something. All right, so that's the brief introduction to the feature store. This demo is relatively simple. It's more of just getting your hands on it and showing you how to integrate with it. But as I said, there's a lot more advanced things that you can do with this. Before I jump into this, is there any questions on MLflow or anything before I jump into the kind of next topic? Cool. Sounds good. And I'm going to be going back to MLflow to show off a couple more things once that run is done. Let me open my second demo here. And give this a second to load. So yeah, here's our feature engineering notebook. Again, this is a notebook from Databricks, and I'm using for our example purposes. And as I mentioned, this can get really advanced. We're looking at the introduction notebook, which is basically just how to set this up and how to use it. And you can get very advanced with this. And I don't think I will have time to talk about that. So, because I'm already about halfway through time, but I'm doing good. I'm doing good. That's what I was thinking. All right, so the idea for this one, we're a data scientist at a travel booking company. So we have a table of essentially, imagine like you go look up travel booking for November 18th. It shows you a whole bunch of different things for November 18th. this table is basically showing us, okay, this user saw this one. Did they click on it? Did they interact with it? Where was the user when they saw it? And a couple other things, which let me scroll down to the actual data to show you. So here's our data. Purchased, if the user purchased this booking, this is the user's ID. This is going to be important later on. The destination ID, this is another ID that will link to a destination table. We have the latitude, whether they clicked it, a booking date, price, and then we just have this kind of standard auto-generated ID just to keep track of things. Here's some analysis, and this looks crazy, and that's mostly because most of this data doesn't really correlate very well. The only thing we can really see here is there's a little spike. If the price is a little lower, because this is orange is they will purchase it. If it's a little lower, they have a little more likelihood to purchase it. And that's all I can really get from this data from the time that I've been prepping for this. But the data itself doesn't matter. We're mostly focusing on how to make a feature table here and how to deploy it. So here's a little better view here. I like this view for what we're looking at. Here's our silver data. That's that transaction table we just looked at and its features. We're going to be turning it into this for our actual features for training. And you might notice some quirks in here. Day of week sign, day of week cosine, day of month sign, day of month cosine. Does anybody know why we're using sine and cosine here? For our, I guess, timestamp values, more or less. Yeah.
Periodic feature for the
Yeah. So we're looking at days of weeks. So we're looking at when in any given month they purchase it, and these are all circular to some degree. The 31st is next to the 1st of any given month. Sunday is relatively next to Monday, and basically they do some math, turn this into a circle so that the model understands, okay, Sunday is right next to Monday. Our midnight is right next to 1 a.m. So it knows that relationship and it can see that they're close together. Because if we use something like categorical labels, let's say 1 through 7 for weekdays, let's say 1 is Monday, 7 Sunday, those are going to look really far apart for the model and not seem to be like a cohesive circle. It's not going to loop back on itself. So this is more just so the model understands that looping circular effect. So here's just some basic setup. We're creating the table. We're doing those circulars here, divided by 7 for days a week, divided by 30. I guess they chose 30 for how many days in a month, 24 hours in a day. And then here, our purchase is going to be our prediction label. So now we have all of our features in this big table here, and these are what we're going to train our model on to understand it. So now let's set up a Databricks feature store to actually store these features for us so that we only need to give it an ID to predict a label or to do training. So this is some Databricks specific stuff. We're creating a feature engineering client. This basically just tells it use the Unity catalog within your current workspace to push whatever it needs to. And here we're creating a table. Relatively simple, just a few attributes. Basically, we're giving it, this is the name of the table we want to run. This is that primary key. So this is how we're going to link our features to an ID. This is that column of the ID. And that can, it can be called whatever as long as it's your ID column you want to look up. The DF, this is just our data. So this is that feature data we created up above here. Oh, I'm scrolling on the table now. And description and tags again. So just like MLflow, they allow you to mark up everything you need so you can find stuff a little easier. And if you're familiar with Spark or Databricks in general, there's a few different ways to create this table if you really wanted to that are a little more, I guess, Sparky is the right way of putting it, rather than like a Databricks kind of specific SDK implementation. All right, so I've ran this notebook beforehand. This one didn't really need too much of a live walkthrough. Let me open my catalog view on the side here. In my DB demos, this is the FS travel tables. So now, after we've run that statement, it's created this destination location feature store for us. And this just sits as any table within your Databricks Unity catalog. The only thing that's really telling us that this is a feature store is the primary key is noted here in the UI. But other than that, this you can interact with like any other table. But where the fun stuff comes in is when you actually want to use the features within this.
Is there like a join feature, like where some flexibility where you can add more?
Yes. I'm just going to pop open the advanced notebook real quick, just to kind of, there's an image in there that kind of highlights what you're going for. Because essentially, I'll get to it in a second. There's a way so you can set up, when we send an ID, here's this ID goes to this table, this ID goes to this other table. So like there's a destination ID in our example. So the advanced version of this, and let me find the image. Oh, that's the table here. There we go. Let me zoom out. Yeah, so this one, there's like a couple tiers to this demo. I'm just going through the simple one. This one, it uses our same silver data of our travel purchase. This time it creates two different tables. So one of them is a weekly view on each of our destinations, how many times it was interacted with, and then the user's info for when they looked at it. And then those two together, which I'll show in a second of how to actually show the API, how to join these together. But with this advanced one, you can send it a user ID and a destination ID, and it'll find both those features for you, and it'll do all the work kind of behind the scenes to join those. And then the advanced one gets more into the timestamp, making with the training to make sure there's no time travel leakage or anything like that. But as I said, I just kind of, for time's sake, I was just scratching the surface. But that was a good point. I did want to bring up that chart, so that gave me a good excuse to pull it up. All right, let me get back to where I was. So we've created our feature store, essentially a table with some special attributes in Databricks, so it knows that it's a feature store. And now, if I remember where I was in my notebook, here we go. Yes, all right. Let me zoom in a bit. All right, so we've made our table. Now here we're just telling it, all right, get this table using the feature engineering API. And now we want to actually train off of this featured data. So as I said, all we need are the IDs. For this, we're basically just ripping out the IDs from that silver table for example purposes. But here, all we need to provide it for training is the IDs and the labels for those IDs. So in our case, just the ID column and the purchase column. And here's that part where I was talking about where you're linking stuff together. So you create what are called lookups, and this one is a very basic one. We're just saying, okay, we want to use destination location FS. That's that feature engineering table we created. And this is the ID column that we want to look it up on. And if you wanted to, you can specify, oh, I only need features A, B, and C rather than A through Z if you wanted to. Then we create a training set, which all we do is we pass it that data frame of IDs and our training labels, and then our lookup information. So we're not actually getting the features ourselves. We're just telling Databricks how to get those features, basically. And another thing with this that this example doesn't really go into, you can also create, I forgot exactly what the term is, but essentially like dynamic columns. So if you needed to compute a distance or something for one of your training metrics or inference metrics, you can add another field in this list that you can link to a function in SQL and it'll compute those on the fly. So yeah, we're creating our training set, and this is going to be, the next few sections are going to look just like the MLflow we were looking at before, so I'm kind of just going to breeze through those. We create our training set. We're excluding some of the columns that don't need to be trained upon, since these don't really affect, we're not using these for our training. And then this, we're just telling it, okay, we want the output label to be purchased. And here they just pull out the data. Basically, this is basically our silver training data. You wouldn't really do this. This is mostly for example purposes, just to show you that essentially this is our training table all put together. But it does that behind the scenes, and they just pulled it out manually. All right, so now we're going to train our model. Same thing as before. We're just doing a train test split here. We do a bunch of logging. Here's that MLflow start run again. We're using a different model here. Not really going to go into specifics too much with this. That's what the other MLflow notebook's for. But as you can see here, you can actually log the whole input if you wanted to. So here it's logging the input of the data set that it's using to train on. So then you can log all the records that you use to train this specific example on also. So this is what I was kind of saying. MLflow is pretty adaptable to your needs. You can log whatever you need. You can choose what you want to log and what you don't want to log. So it's really nice that way. And basically, after all this is done, we log our model using the feature engineering. And basically, again, this is kind of like when we created the lookup. We're just kind of giving it the things we need so it knows how to find this later on. This is the model we just made. This is the path to it. And here are the couple things we use to put it all together. Training set, here's the name you want to use. The flavor, that's basically just telling it what libraries we use to create this model. Does a bunch of training, that's what all this output is for. And now, after all that's done, so we've run the training, we've trained our model, we've logged it. Now it's going to show up in our Unity catalog. So now we get a little Databricks action. And if we, in our Unity catalog on the left side here, there is a models tab once you have a model. And I can click on this, and let me open this up in a different tab. And you can see your model directly within the Unity catalog. So that's one way I like Databricks and MLflow together, is because you can keep your models right next to your data. So you know, okay, this model is with this data set because they're sitting in the same schema. And with this, you can do all the same things you could with a table. You can add descriptions. This is being pulled directly from MLflow down here, so you can see the different versions and details. I was trying to find, I don't know where it went. Usually there's a lineage tab here, so you can see what tables were fed into this model. I might be just looking in the wrong place right now. The button is not where I expected. But somewhere you can see where the lineage is, so you can see what tables go into it. And then permissions, Unity catalog permissions, all that fun stuff can go right on top of your models. All right. And yeah, here's the picture of the table lineage. I just forgot exactly where that button was in the UI. But essentially, yeah, you can see what tables feed in to train your model, and you can see that for each version too. Same thing we did before. We're labeling that model as the production model. Things I've already demoed. Now here's where the kind of the power of the feature store comes in, is when you actually want to run inference. So training, I mean, you can do that using sklearn. If you know how to do that, it's relatively boilerplate. You can use it using the feature engineering. But if you actually want to inference on this is where it becomes really nice. So what we're doing here, this line, all we're saying from our training data, this is just for example purposes, we're just grabbing all the IDs. That's all we need to infer on it. As long as the ID's in Databricks, and we have an ID for it, we can pull the features right out of it. So here we're just scoring batch. So this is basically saying, here's that model we just created, save them in variables so we can refer to them later. And here's our data frame of IDs. Result type, we're just saying is Boolean. We just want to see if it's true or false, if they're going to buy this or not. And after all of that, we get the results out, which this is all of our data, and then we get our prediction label at the end. So this is I'm pretty sure this is if they're going to purchase it or not, is the prediction label. And that's really it. So as you saw, as I pointed out in the advanced notebook, it gets a little more advanced, especially when you start adding multiple tables. That's kind of where the power comes in. So as I was saying, it's not really about like these small scale example. It's more about the scaling. So once you start getting tons of different data sets, you need to join together, and you can deploy this to an API endpoint in Databricks. So let's say you have a mobile app or something, and you want to do some kind of personalization based on features you have in Databricks. If your mobile app knows the user ID of the user that's logged in, you can just hit the endpoint with the user ID, and you don't have to worry about moving all that data to make sure it infers correctly. Databricks will handle all that for you. So this is a cool little nifty feature. I just wanted to put a little attention on it. Is there any questions at all about Feature Store? It's kind of just the brief introduction I wanted to give on it. Cool. Looks like I have about 15 minutes slotted left. Let me. Yeah, go ahead.
It's kind of a dumb one, though.
Yeah.
Feature Store is working with Unity Catalog now?
Yep. Yep. Feature storage directly, and as I said, it more or less it's basically just a table. You just have to do some special syntax to make it show up correctly. But yeah, I really like it for its use in inference. You only need to send it one value to run an inference rather than having to pull out all of your different features, send it to a server or whatever. It'll handle that all behind the scenes as long as you have your ID. Yeah.
Instead of, relative to the prediction, instead of like a truth table, you can run like if else
Yeah.
kind of scenario, right? Like different types of expressions.
Yeah. This was a very, like, in that lookup, you can kind of build out whatever you need for your data set, whether that's dynamic, if it's like a simple if else check or something like that, it can really grow. So like, since we're still talking about it, let me go back to that advanced example.
That's where the true power is.
Yes, yep.
Customize it.
Yep. So in this example, we have the two tables. Instead of just like the one user table, we have a destination table now. And I just wanted to show the one section where it kind of builds those together with the code. And this is all building data. All right, so this is creating the feature table. As you can see here, since this is this has that timestamp variance, you're also specifying a timestamp key here, so it knows how to keep track of that. And I'm looking for where it wants to create the lookup. There it is. So as you can see, we're creating, it's just a list of different feature lookups you can add in here to do whatever you need. So you can add more tables, and if I go to the expert one, I think they add in some dynamic ones, so you can kind of load in however you need.
But that's where the business rules can be
Yeah.
added, right?
Yep. Exactly. Yeah. So the introduction doesn't really show the full power of it because it requires a lot more time to really get into depth with it. But I wanted to introduce it so everybody's kind of aware that this is a nice feature that exists within the Databricks. But yeah, any other questions on feature stores at all? Cool. All right, I'm going to hop back, finish up my MLflow demo, and then I'll give a real quick spiel on Lakehouse data monitoring. All right, so we have trained our model. I think, let me see where I ended up. All right, is this, yeah. So we have 97 runs of an experiment in MLflow. So that was all running in the background while we were talking about the feature stores. We ran this experiment. It trained 97 different models. Now we can go to this experiment view and we can see which one was best. Nice thing about this chart here, if I can get it to the right view that I want. Maybe I'm just too zoomed in. There we go. That's the button I was looking for. Anything that you log, this is kind of a Databricks MLflow thing because it's got a nice UI on top of it. You can add columns of metrics that you've logged. So let's look at the AUC score of every model. We can add that as a column. So now we have a column for the AUC scores that we logged. And let's see, I think it's already default logging it by the most to the least. Now I can organize them by the highest AUC score to the lowest AUC score based on those 96. As we can see, the highest was 0.896-ish, relatively good score. This was the Rambunctious Wolf 3 model. And you can go into this. There's going to be a couple extra things logged here automatically. That's coming from that XGBoost library I mentioned. It does some things automatically. So that also finds like a loss for you, the best iteration of it, where it stopped, the log loss. And then these are all the parameters that were used to train this model. And these are all kind of specific to the XGBoost library. I'm not going to go too in depth on there, but those could be whatever you want for whatever model you're training. But then you can see exactly what was here. We go to artifacts. We can see, okay, this was all the code. These are the weights for everything that came out of it, and then we can reproduce it. The next step now is, so we've created one model. We've labeled that one as production. That was our first one. Remember we made that baseline model. We labeled it as production. We're saying, hey, that's a production model. Let's use it. Now we have a better model. So now we want to promote this new model as the new production version. This is just showing how to run the model. Here we go. So now we are using this MLflow. We're just saying, okay, grab the highest AUC score, and that's going to be our best run. That's the one we want to use to register as our new model. Let me run that. And then we register it the same way as before, just using a special URI. This is the run that we want to make as the model. This model name is wine quality. We defined it way earlier in the notebook. And we can hit run, and it will create version 2 for us. So we didn't have to tell it was version 2. It just saw there's another model in there, and here's a new one, so it just labels it version 2. This does not change our production tag, though. That version 1 is still labeled as production. That's going to stay as production until somebody changes it, which is what we're going to do next. So, as I showed earlier, you can do this through UI, you can do this through code. We're going to move the old version to archived. We don't want to use that version anymore. And this new version to production. And we run that. It'll switch them around for us. It takes like 1 second to run that. And now this is that exact same cell we saw earlier for this model name / production. But now it's going to grab the version 2 because that one's labeled as production. And it actually got an even better AUC score than it actually logged to the experiment. It got a 0.9. It just beat it by like 0.004. But yeah, so using the same exact code, we're now using the newer model rather than the older model. And this is just showing batch inference on that model. The other thing I wanted to point out is if you're used to Spark and Databricks, you can easily push this into a user-defined function. So you can do so we're calling this model as a user-defined function, apply model UDF. So this function is just going to take in the columns that we want to run, and we can run it. If you're used to Spark, we can just say with column, prediction, apply the model UDF, and our columns are just all of our columns. And then it will just add that column, and it'll run the model for us, and you don't really need to do any more work on top of that. It'll pull it out of the registry, it'll run it on all your columns, and as you can see below, here's all of our wine data, and if we look to the end, here's the prediction that it outputted for each one. So most of these are pretty low. This one is probably a high quality wine because this is near 1. This one is definitely not a high quality wine because this is nearing 0. But yeah, so it's really easy to integrate it with existing workflows within Databricks. Last little thing on, just want to show how easy it is to serve the model. So we have our model in our model registry. You can see it here. So I have a wine quality. Now it's at version 2 because we pushed the second one. And if I go to serving, let's say, okay, this one's production ready. Let's use it in our web app or something like that. Easily within Databricks, we can create an endpoint. I can name the endpoint whatever I want. Demo, select an entity. I want to use my models. And there's my wine quality model. You can select a specific version if you really wanted to deploy on this one. And then you can select how big you want your cluster to be, scale to 0. You can do all the normal Databricks stuff on this custom model that you just made. And then this will create an endpoint, and you can query it from anywhere as long as it has the proper authentication. So yeah, that is kind of the whole rundown of MLflow. Is there any last questions on MLflow at all? Cool. Yeah, so that kind of walks through, looking at data, doing experiments, make a model off of those experiments, and then ultimately deploying that model for production use, all using MLflow within Databricks. Let's see, I got a few minutes left. I'm just going to quickly go through Lakehouse monitoring. I don't really think these slides are too important. Essentially, it's really good at figuring out how your data is changing and when it's changing are kind of the core tenets. So the example notebook that I'm going to open up is looking at, I forgot what the payments are for. It's a payment database, and we're looking at the different types, the preferred payment methods that came through. So the example here is basically all of a sudden, we saw a whole bunch of nulls show up in our preferred payment method. We don't really know why, yes, but this just started showing up. Maybe business users are looking at their analytics dashboard or something, and all of a sudden a bunch of nulls start showing up, and they start sending you a bunch of messages because the data's all wrong. So the idea of this will help you figure out where those came from and why those happened. So 3 questions that we're going to answer. What % of nulls have been introduced? Is that normal? If it's not normal, what's the root cause? What are the downstream assets that might have been impacted by this issue? And really all this notebook does is we're going to look at our data, and then we're going to create a monitor, which a monitor is basically saying, what is the time range we want to look at? Do we look at a day, an hour at a time to see how things are changing, get analytics on that? We can set a week if we wanted to, we can set a month, whatever time span you want to look at. And then for this one, we're just looking at toy data apparently. So it's just setting a slice here. It sets that all up, and then it creates a monitor through code here. You can also do this in Databricks through the UI. I'm just going to pick on some random table here in my Unity catalog. So let's say silver transactions, that's what we were looking at before. So you could do it through code, give it the properties, call a couple APIs, set it up through here. You can also, as long as this one doesn't have it set up already, this one is already set up with it. Let's pick this one. If you go to the quality tab and it's not set up, you get this little, oh, set me up thing. You click it, you select the type. Time series is the most common. You can also do this for if you want, if you're like, let's say you're logging all your models outputs to a table, you can see how the inference is drifting over time. Inference drift, the easiest example I remember from MSOE was you train a model on spam data sets. The people who are making the spam emails are going to slowly learn how to get around the spam detector, so your results are going to drift. So this will help analyze and find those and figure out why. But same things here. We can select type, time series, the granularity we want to pick, timestamp column. This is just so it knows how to split up that data. And you can also do like advanced options if you wanted to. So you can set up notifications if there's certain thresholds that are hit. Let's say some column, 50% of nulls started showing up out of nowhere. You can set an alert so when it hits that threshold, it'll send a Teams notification or an email out to your team or something like that. But the thing I really want to show, so we set up the monitor, and then it'll create two tables based off of the table we tell it to look at. One of them is the profile table. This table is basically looking at every column. And let me go to the better example where it filters it down a little bit to good data. There we go. The profile table, we're looking at the column total purchase amount. So as you can see here, it sets up a window for one day. That was the granularity it gave it. So every day, it's going to grab metrics on every column. And we're looking just at total purchase amount here. So just scrolling through the table, we can see there was 110 rows that had a total purchase amount. None of them were null. Here's the average value, quantiles, min, max, standard deviation. All these are computed automatically for us and stored into a table. So you don't need to do any of that. You can just query this table and find, oh, the standard deviation on Thursday was huge because one guy paid $5 million for Oreos or something like that. So you can see all that info here without having to compute it yourself. The other table it creates is the drift table. So this is comparing, let's say, since we're at a one-day window, today versus yesterday, yesterday versus the day before yesterday, and it'll compare every day versus the last day. So then you can see, okay, what is this? This is the April 30th this is April 30th compared to May 1st. There was 6 more total purchased amount columns. The average went down by about 120-ish, and a bunch of other fun statistics in here. This is all computed just by clicking a few buttons. It'll take, if you have data in the table, first time you start it up, it's going to take some time it'll go through all the existing records and compute these for you. So it takes a little time to start up initially. But once it's set up, it'll automatically query any new data that gets dropped into it. The nice thing about this is we get an auto-generated dashboard. And I'm just going to go a few minutes over just so we can answer those couple questions at the top quick. So going to the dashboard now, let me just find that quick. This is the silver transactions. I clicked on the wrong table because this is the actual demo table. Quality. When you go to the quality tab, after it's configured, you can edit it if you need to, change the granularity. Maybe you wanted to change it to a week instead of a day or something. Then you can view the dashboard. So we want to figure out, we have 3 questions we want to answer. Let me scroll to the top to find those questions. We want to figure out what % of nulls have been introduced in this column. Is that normal? So we go to our dashboard. If this is, it's not going to be live because I forgot to boot up the warehouse. Actually, this is a quick warehouse. And let me refresh this. So right now, I just started up my warehouse. Yes, I know. I just started this. It's going to be booting up in the background, but we can still see the stats that have already been computed. So everything you see in here, behind each cell is a SQL query. This has all been generated for us from the monitoring. It's done running. See the row count over time. You can see that May 19th, there was a slight uptick in row counts. And okay, here's our % nulls over time. And the column we want to look at is the preferred payment method. And as we can see, things were relatively normal until May 19th, until yesterday. Everything started going haywire, and we got a whole bunch of nulls in our data. So now we know when this happened, but now we want to figure out, I'm pretty sure the next question, just to confirm, that's not normal, as we saw. It hovered around 5%-ish, and then it spiked to, what did it spike to? 55%. So that is not normal. So this is not normal. Now we want to figure out what is the root cause of this issue. So behind the scenes, there's a table of all the transactions, and that table has not the preferred payment method, but the payment method they used. And that will give us a clue onto why the preferred payment method all started going haywire. So if we scroll down a bit, there's another chart in here. Let's see, not the range over time. There's one for categorical data that I'm looking for. Categorical distribution over time. Right now we're looking at all the columns, so this doesn't make any sense. Let's filter it down to the payment method that was used for each purchase. That's going to update our view here, and now we can see some interesting info. We can see that on May 19th, the day where things started going haywire, it looks like a new category was introduced of Apple Pay. So now we know why that happened. We added Apple Pay to our app, and that's not a preferred payment method. So all of a sudden, all these nulls started popping up because we haven't attributed this new attribute that showed up. But before that, everything was more or less relatively normal. So that answers question 2. That's the root cause. Apple Pay showed up and caused the issue. Now we want to see what are the downstream assets that have been impacted by this. And this one is just a little bit more theoretical, but with Databricks, you can see the lineage. And this is the button I was looking for in the model, and I couldn't find it. You can see the lineage. So now we can see exactly what tables feed into this table that caused the error, and where the data in this table is going, where things might start seeming off. So we know what's impacted and where it came from. So here's our silver table, and we can see we have profile metrics table that it feeds into, the payment method table. So now we know, okay, maybe there's on this gold user purchase table, maybe there's a dashboard. Maybe we should inform our users that we're working on, people who look at that dashboard should know that we're working on the fix, so this null issue will go away, or whatever you need to do to rectify the issue. And then you can also see where it's coming from. So this is coming from, most likely, bronze transactions, and it's really small right now, but in here there's the payment method. So this is the table where it's coming from, and you can see how other tables feed into it. You can expand these, you can zoom in if you really wanted to. But yeah, so that was the real quick, because I went a little too long in my MLflow portion, but that was real quick lakehouse monitoring. Basically, if things start changing in your data, this is going to show you, this will make it a little easier to figure out why it's changing and where it's changing. And that more or less wraps up what I was going to talk about today. Is there any questions or anything before I kind of stand down?
People online too, so you might want to
Yeah.